Welcome, ladies and gentlemen. So what I'd like to do is show you how to graph the cosine function when we have a change in the period. So what I have here is two examples. I have y equals cosine of 2x, as well as y equals 1/2 of cosine of pi over 3x. And then I also have, bx here. And then I also have the parent graph of cosine, or what we call like the initial period. Basically, that is just y. That's the initial period of y equals cosine of x. That means there's no change in amplitude, no change in period, or the amplitude would be 1, the period would be 2 pi. Now what we're going to be dealing with is when we have cosine functions with an a and a b. Remember, a represents your amplitude, and b is going to represent our period, or our change in our period. So the first thing we want to do whenever we're graphing the trigonometric graphs is identify our important information. And the first thing we want to identify is the amplitude. Now remember, the amplitude is represents the absolute value of a, which is the half distance from the max to the min of our point. So the absolute value of a in this case, you can see our a here is 1, right? There's not, you don't see the ones. So there, it's right there. Absolute value is just going to be 1. Now when I'm going to go ahead and graph this, when I have an amplitude of 1, now as long as there's no vertical transformations, I'm not shifting the graph up or shifting the graph down, then I can just basically, the amplitude, since it's the half distance between my maximum and my minimum, well, I know that the x-axis is going to be that half distance here, right? So I can just go to 1 down to -1. Now the next thing is going to identify our period. Now our period is going to be our pi, or sorry, our pi, 2 pi, which is from our initial period, divided by b. Well, in this case, our b is 2. So therefore, I have 2 pi divided by b is how we find the period. So therefore, I take 2 pi divided by 2, because that's our b. Here's 2. So therefore, you're just left with pi. So that means rather than our initial period completing one cycle in 2 pi, it's now going to complete it in pi. Now, I'm not drawing the exact same representation. I just want you to kind of see that. Now, the other important thing to notice about the initial period is you can see that it's broken down here. There's there's actually technically 5 critical points here: the maximum, intercept, minimum, intercept, and then maximum again. So we want to be able to figure out, well, the distance between all of those is equal. So we want to be able to find out, well, what is our x scale? How are we going to scale the rest of, we know it's going to complete a period into pi, but how are we going to scale the rest of the graph? So to do that, all we're simply going to do is take our period and divide it by 4. So our period here is pi over 4. Oh, it's pi divided by 4. So that means I'm going to break this up into fourths. Okay, so meaning the distance from 0 here, that's the y-axis. 0 is going to be pi over 4. Then you could do 2 pi over 4, which is really pi halves. 3 pi over 4. 4 pi over 4, or pi. And I'm going to actually draw 2 periods here. So that would be 5 pi over 4. 6 pi over 4, which can reduce to 3 halves. 7 pi over 4. And then 8 pi over 4, which is 2 pi. So I'm actually going to be doing 2 initial periods here for this graph. All right, so now we basically have everything. All I'm doing is now just going to transplant this initial period, what the graph looks like. So again, our initial period, we start here. Then we go to our intercept, our minimum, back to our intercept, and then back up to our maximum. So you can see here the graph. Remember, we said the period, it goes through between 0 and pi. So we start at 0, and it goes up to pi. Now that's 1 period. Now I'm going to complete 2 periods. So again, just going to fill in the information again. Boom. So there you go. That's kind of what pi. So you can see now we have 2 periods. And you can keep on going, but typically I only ask my students to do 2 periods. All right. So now let's go ahead and graph y equals 1/2 cosine of pi thirds x. So you can see now we have some fractions, which is lovely, right? So the first thing we're going to want to do, again, just like we did before, is determine the absolute value of a. Well, in this case, we have our absolute value. Our amplitude is the absolute value of 1/2, which is just going to be 1/2. Now, again, there's no transformations or vertical transformations shifting right or down. So therefore, no, I always make it go down. So hard. Teacher problems. OK, so if we're going up to 1 down to -1, like in the last example, well, now I'm only going to go as high as 1/2 and down to is -1/2, where that's still 0. Okay, so the amplitude, remember, is that half distance. Well, the distance from the max to the min, you can see up here was 2, right? So the half distance is 1. Half distance between 1/2 and -1/2 is 1. Half of that is going to be 1/2. So we're good there. The next thing is going to be the period, and this one gets students all the time. So again, we take 2 pi. Now you can see, well, what is being multiplied by a pi? And there's a couple actually different variations you could see here. We could have this as pi over 3x. We could also see this as pi x over 3. Either representation is exactly the same, okay? So it's very, very important. This one's kind of obvious. Say, oh, pi thirds times x. But a lot of times you'll also see it as pi x divided by 3. So therefore, you got to understand that these are exactly the same, meaning that my b is going to be pi thirds, okay? Now, whenever we have a number divided by a fraction, to undo that, we multiply by the reciprocal. So I will multiply by 3 over pi. 3 over pi. Well, any number multiplied by the reciprocal is going to go to 1. Here, I'm now multiplying a whole number times a fraction. The pi's will divide out to 1. And then I have 2 times 3, which is 6. So that means now it completes a period in 6. Well, you might say, well, last one was pi. Now this one's in the number 6. You know, how exactly does that work? And actually, what I am going to do here is I'm going to do the y-intercept right in the middle here. So I'm going to go up to 1, down to 1/2, 1/2, -1/2. OK, so instead of doing 2 periods to the right like I did up here, I'm going to do a period to the right and a period to the left. All right, so in this example, what I'd like to do now is go ahead and distribute. Well, if we're going to do 1 period, then we're going to go up to 6. So just like you scale like a number line, now we're just not using a number line that's in terms of pi. We're just using actual just integers. And then we'll go to -6. So a lot of students should kind of like this here. We're just saying, all right, well, what are we, the periods is not going to be dealing anything with pi. Then the last thing we're going to have to do is do the x scale. Okay, which again is going to take your period and divide it by 4, which 6/2 you can redo to 3/2. Okay, or 1.5 if you want to use decimals, but we don't like using decimals. So anyways, just like I did before, I'm going to take my period and break it up into 4 separate sections, right? So I can involve my critical points. So there. And a lot of times the reason why I like doing positive and a negative, and usually this kind of depends on what your teacher is asking, if they ask for 2 periods. But a lot of times, whatever I do positive, I'm just going to do the exact same negative. Whereas this one, I had to keep on adding the fractions, which is not bad, which is good actually for you to get used to fractions. But should be versed either way. So we know that our x scale is going to be 3/2. Okay. So therefore, to go from 0 to 3/2, then I'm going to add another one, which would be 6/2. Then I'll add another one, which is 9/2. And then I'm going to add another one, which is 12/2. And the reason why I'm doing this, again, is just to show you how the fractions kind of work. So 3/2, 3/2 plus 3/2 would be 6/2. 6/2 plus 3/2 would be 9/2. 9/2 plus 3/2 would be 12/2. Well, that cannot be reduced. 6/2 can reduce to 3. 9/2 cannot be reduced. And then 12/2 we know, or 12/2 we know can be reduced back to 6. So now I'm just going to do the exact same in the negative direction. And we already have -6. OK, so very good. So now we just have our graph. So we're going to start up here. We go to our intercept, minimum, intercept, maximum. OK, then if you just follow the pattern, just kind of follow the pattern backwards. Well, if I start at my max, then I'm going to go to my minimum, or my intercept, minimum, intercept, back to max. I think that should be right there. OK, so there you go, ladies and gentlemen. That is how you graph your cosine function when you have a change in period as well as amplitude. Thanks.